Graph using the slope and the y-intercept. In order to graph a line, you must graph at least 2 points on the line. There are several ways you can find those 2 points. One way is to find the x-intercept and the y-intercept. The nice thing about this method is that you're plugging zeros into your equation, so it makes it very simple to do the arithmetic with those numbers. Another way of finding your points is to make a table and pick numbers. You can pick any number you want to use and plug it in for one of the variables. Work it out to find the corresponding value for the other variable. That's also rather simple if you use easy numbers. A third way to do it doesn't even involve any calculating or even any plugging in. From the equation, we want to use the y-intercept for the first point, and then use the slope to help us get the second point. So let's look at how we'll do that. Here the equation is y equals 3x minus 2. Now because this equation is in what we call slope-intercept form, I know that the coefficient of x is the slope, and the constant term is the y-coordinate of the y-intercept. So I know my slope here is 3, and my y-intercept is the point 0, negative 2. That's the point where your line crosses the y-axis, so that would be right here. Now, this is our first point. Now we look at the slope to help us find the second point. Remember that the slope is a ratio of rise to run, which means from any point on the graph, if I use that ratio of rise, in this case it's a rise of 3, 1, 2, 3, and a run of 1, that will give me another point on my graph. Then I could do the same thing again. Rise 3, run 1. Rise 3, run 1. And I can get a whole lot of points very easily. So here is my equation of my line. You only had to find this point and the second point, but you can go very easily and find the other points. Let me also show you, let me change colors here for a second. To the purple. I could have started from this same point and used a slope ratio of negative 3 over 1, in which negative 3 over negative 1, because that's the same as 3. So I could have gone down 3 units and to the left 1 unit. Down 3 to the left 1. And I still would have been on the same line. Now here's an equation that is not in slope-intercept form. To use the slope and the y-intercept, your first step has to be to solve your equation for y. You have to have it in slope-intercept form to know what your slope and your y-intercept are. So I'm going to take this equation, 2x plus 6y equals 12, and I want to solve it for y. That means I need to subtract the 2x from both sides. The 2x is in the way over here. So I get rid of it on the left side. That leaves me with just 6y on the left, but it gives me negative 2x plus 12 on the right side. Now I want to divide by 6. So I'm going to divide each term individually here by 6. That will give me y equals a negative 1/3 x plus 2. So this time my y-intercept is positive 2. And my slope is a negative 1/3. So let me go to my y-intercept first. That's my first point. I plot it. And from that point, I use my slope to get my next point. Because my slope is negative, I'm going to think of that as a negative 1 over a positive 3. So that means I would go down 1 and to the right 3. I could do it again, down 1 and to the right 3. Now if I had taken and plugged a 3 in for x into this equation, I would have gotten this same point. I still would have come up with a y value of 1. So then I want to draw my line. And there's my line. I also could have thought of this as a positive 1 over a negative 3, which means from this first point I would have gone up 1, but to the left 3, and it would have gone through that point right there.